When you picture the night sky, you might think of something eternal, unchanging, patient, and familiar. The stars that guided sailors and dreamers centuries ago still hang above us tonight, faint and constant, watching. But every so often, the sky offers something different, something fleeting. A glimmer, a wanderer, a visitor from far beyond the map of our solar system. That's where our story begins, with a speck of light so faint, most telescopes ignored it. The kind of thing that could easily be mistaken for noise, a blip on a sensor, or a smudge of dust on a lens. But this one wasn't noise. It was 3I/ATLAS. Before we begin properly, though, take a moment to make yourself comfortable. This is not a story that needs your eyes, only your imagination. You don't need to keep watching the screen. You don't even need to stay awake. This is a documentary for sleep. You can close your eyes, let the sounds and words drift through you, and let your mind wander as we travel quietly into the deep. And while you're settling in, I'll gently ask, if you enjoy this kind of soft, late-night storytelling, you might consider subscribing or liking this video. It helps more than you know, and it's our way of keeping this small, cozy corner of the internet glowing. But for now, there's nothing you need to do except breathe, listen, and drift. So, back to that faint speck. The discovery came quietly, as most great discoveries do. In early 2020, the Atlas survey, an automated telescope system in Hawaii, was scanning the heavens as it always does, for anything that might move, flare, or threaten our planet. Its instruments recorded a small point of light, just slightly brighter than the darkness around it. Nothing remarkable at first. But when its motion was tracked, astronomers noticed something strange. It wasn't circling the sun. It wasn't even bound to it. Most comets and asteroids follow predictable orbits, ellipses and loops shaped by gravity. But this one didn't curve gently like a returning traveler. Its path was sharp, open, hyperbolic. That single word meant something enormous. It wasn't from here. The data confirmed what many suspected, but few dared to say aloud. 3I/ATLAS was the third confirmed interstellar object ever found, after Oumuamua in 2017 and Borisov in 2019. Another visitor from the vast, uncharted reaches of interstellar space. But this one, from the very beginning, felt different. It wasn't just that it came from far away. It was the way it behaved once it arrived. When scientists plotted its speed, the numbers didn't sit comfortably. More than 60 kilometers per second, far faster than anything expected from a wandering rock casually ejected from another star system. And the way it brightened, even before nearing the sun, raised eyebrows. Comets usually awaken when warmth stirs their frozen gases, but 3I/ATLAS seemed too eager, glowing sooner than the laws of thermodynamics would politely allow. At first, astronomers chalked it up to coincidence or miscalculation, or simply the strange luck of cosmic odds. But quiet questions began to rise. Was this just another rock, another cosmic snowball tumbling through the void? Or was something else at play? You see, every time a new interstellar object passes through our neighborhood, it brings more questions than answers. Oumuamua moved too fast, too precisely, and reflected light in patterns that defied explanation. Borisov, the second, seemed more conventional, a comet through and through, but its speed still puzzled researchers. And now, Atlas 3I, the third visitor, followed the same rule of strangeness, each one faster, each one rarer, each one slightly less natural. For the scientists watching, that raised an unsettling thought. What if there was a pattern here, one we were only just beginning to glimpse? As the data poured in, the first analyses confirmed the hyperbolic path beyond all doubt. 3I/ATLAS wasn't from the outer edges of the solar system. It came from the outside, from somewhere beyond the reach of even our sun's influence. Imagine something traveling for millions of years, crossing the cold silence between stars, brushing past systems we can barely see, and finally, by pure chance or design, passing close enough for us to notice. When telescopes caught its faint tail, the comet looked ordinary enough, a small, icy nucleus shedding gas and dust. But beneath that simplicity, the numbers whispered a stranger story. Its velocity vector didn't quite match the distribution of interstellar debris we'd expect. Its chemical signature, at least what could be measured, was inconsistent with known comet types. And most curious of all, the simulations of its origin gave no satisfying answer. Astronomers, cautious as ever, avoided grand claims. Space is full of anomalies after all. Yet a quiet tension hung in the air. The same feeling that lingers when you sense something watching you, but can't quite find the eyes. For every solid explanation, there was another unanswered question. For every natural pattern, there was one too neat, too precise. The more they looked, the more the data seemed to hint at something beyond randomness. But no one wanted to say it out loud. Not yet. And perhaps that's why this story feels different from the start. It isn't just a record of observation. It's the story of suspicion, of scientists who, for all their training, could not shake the feeling that 3I/ATLAS wasn't behaving like a simple comet. Maybe it's nothing, they said. Maybe it's just another frozen rock from another forgotten system. But late at night, when the observatories fell silent and screens flickered with faint, pixelated trails, those same scientists sat staring at that speck of light, wondering what it really was. Because sometimes, the universe doesn't just send rocks and ice across the stars. Sometimes, it sends reminders. And Atlas, faint and unassuming as it seemed, might have been exactly that. A quiet If the discovery of 3I/ATLAS began with curiosity, what followed was a quiet unease, the kind that builds not from what you know, but from what refuses to make sense. The early data had already shown its strangeness, the speed, the path, the way it came alive before it should have. But the deeper astronomers looked, the more that unease grew. There's something unsettling about speed in the void. Space is not a highway. It's a deep, endless drag of resistance, an ocean of invisible dust and gas that wears down whatever crosses it. To travel through that, year after year, century after century, and still arrive moving at over 60 kilometers per second, it defied expectation. That's roughly 134,000 miles per hour, enough to cross the distance between Earth and the Moon in just over 3 hours. And that wasn't slowing down. That was after eons of travel. For comparison, the fastest natural comets from our own solar system move at maybe a third of that speed. And even those are flung outward by violent gravitational assists from planets like Jupiter. Atlas had no such help left. Its journey began somewhere far beyond, its push long spent. So why was it still moving so fast? At first, the explanation seemed simple enough. Every interstellar object must start its journey by escaping a star's gravity well, and that takes energy. But each time astronomers recalculated, the puzzle deepened. 3I/ATLAS wasn't just fast. It was too fast, too consistent. Each of its predecessors, Oumuamua, then Borisov, had been faster than the last, as if something, somewhere, were fine-tuning these arrivals. Coincidence, perhaps, a trick of statistics. But even coincidences have limits, and so, quietly, the idea began to circulate. Maybe this pattern wasn't random. Maybe it was deliberate. The question wasn't shouted in headlines or proclaimed in conferences. It whispered between observatories, tucked into footnotes, murmured in late-night emails between astronomers who trusted each other enough to wonder aloud. Could there be something connecting these interstellar visitors? Something more than mere chance? It was an uncomfortable thought. Scientists are trained to see design only when every other explanation fails. To suggest intention in the cosmos is to step into myth, to invite ridicule. And yet, the numbers persisted. When plotted, the velocities formed an odd sequence, each new interstellar visitor just slightly faster than the one before it. Oumuamua at 26 kilometers per second, Borisov at 32, Atlas over 60. None of them aligned perfectly, but together they traced a trend that felt intentional, like footsteps fading into the distance. If these were natural wanderers, the odds of such a pattern were infinitesimal. It would be like tossing a handful of stones into a river and having them all skip in perfect rhythm. Still, skepticism held firm. The scientific mind resists the extraordinary until forced otherwise. Maybe the pattern was illusion. Confirmation bias, data noise, or coincidence amplified by imagination. You might imagine the astronomers themselves at that moment, sitting before glowing monitors in dim control rooms. The hum of computers, the clicking of keyboards, the faint smell of coffee gone cold. Outside, wind scraped against the domes, and above, the sky moved on, indifferent to their awe. They weren't chasing fantasies, they were chasing numbers, photons, the faintest fingerprints of truth. But the data, as always, seemed to look back. Each new measurement made Atlas stranger. Its light curve fluctuated oddly, as though it rotated unevenly, or had a surface more complex than a simple comet's. Sometimes it brightened faster than the models predicted, then dimmed again, as if something about its shape or composition refused to fit the equations. The mystery thickened, but so did the fascination. Humanity loves puzzles, especially the cosmic kind, the ones too large for our hands to touch, too distant for our eyes to truly see. Among those who studied ATLAS, there were two camps forming quietly. The first saw it as a statistical anomaly, a natural object that simply didn't behave the way we expected. The universe, after all, is large enough to surprise us daily. The second camp, the smaller, more careful one, suspected something stranger. Not alien technology, not yet, but perhaps a phenomenon that blurred the boundary between nature and intention. You see, there's a subtle line where randomness starts to look like design, the shape of a spiral galaxy, the pattern of waves on a beach, the formation of frost on a window. All can look deliberate, though they're born of physics alone. Maybe 3I/ATLAS was one of those, a trick of perception. Or maybe it was something else, an echo of intelligence so vast and ancient, it had learned to hide perfectly within natural law. But those thoughts were for later. For now, there was only the data, that silent cascade of numbers falling across screens, measuring what could barely be seen. As the months passed, 3I/ATLAS grew brighter in the telescopes, then slowly dimmer as it moved away. Observations piled up, but answers did not. Every analysis brought new confusion. The more precise the instruments, the deeper the mystery grew. It was as if the universe itself was teasing us, offering a glimpse, then withdrawing it again, daring us to keep guessing. And beneath the calculations, the quiet question persisted. What if these interstellar visitors weren't accidents? What if each one was part of a story still unfolding, a story we've only just realized we're in? For now, though, the scientists could only watch. They plotted the orbit, ran their models, refined the numbers, and stared into the slow vanishing of a light that shouldn't have existed. The sky above returned to its calm indifference. Atlas drifted outward, leaving behind little more than confusion and the faint, nagging feeling that maybe, just maybe, it had come this way for a reason. The deeper astronomers peered into the faint glow of 3I/ATLAS, the stranger it seemed to become. In the first days, it behaved almost politely, like a comet was expected to, dim and unassuming, drifting in from the cold. But soon enough, its chemistry began to whisper a different story, one that didn't quite fit within the familiar language of space dust and ice. Spectral analysis, those fingerprints of light that reveal what a thing is made of, brought the first surprise. Comets, especially those from the outer regions of our solar system, tend to share a fairly predictable recipe: frozen water, carbon dioxide, carbon monoxide, a sprinkle of silicates, and a dusting of organic compounds. Simple ingredients forged in the same cosmic pantry. But Atlas's readings told a story that didn't match the cookbook. Its ratio of carbon dioxide to water vapor was far higher than expected, so high that even seasoned comet researchers had to double-check their instruments. Some wondered if the data was contaminated or if the models were misaligned, but every recalibration came back the same. Whatever Atlas was, it didn't fit the standard definition of ordinary. And then came another surprise. It began to show activity, jets of gas, a faint tail, while it was still far from the sun, in regions of space so cold that most comets remain dormant. Normally, a comet wakes up only when sunlight begins to warm its frozen surface. But 3I/ATLAS stirred too soon. like a sleeper roused before dawn. That single anomaly raised endless questions. If it was too cold for water ice to sublimate, what was fueling the outgassing? Carbon dioxide could do it, but that would require even more of it than the already unusual readings suggested. The numbers stacked oddly, like a melody out of tune. Something about its chemistry simply didn't add up. At first, the theories were cautious. Perhaps Atlas had been bombarded by cosmic rays during its long interstellar journey. Its ice is baked and altered by countless centuries of radiation. Maybe that radiation had reshuffled its molecular structure, trapping pockets of volatile gas beneath layers of carbon-rich crust. When sunlight finally touched it, those trapped gases could have erupted early, explaining the strange behavior. But even that theory began to strain under scrutiny. The ratio of gases, the timing of the activity, the spectral fingerprints, they all resisted neat explanations. It was like trying to explain an accent you've never heard before. And that's when speculation began to drift into stranger territory. A few voices, quiet, cautious, began to ask whether the chemistry might not just be a quirk of nature, but something deliberate, a disguise. It sounds absurd, doesn't it? The idea that an interstellar object could hide in plain sight, dressed up in the chemistry of a comet. But that's how wild ideas often start, born from the cracks in what we think we understand. If a civilization, somewhere far older and wiser than ours, wanted to send a probe through inhabited systems without drawing attention, what better disguise than a rock or a comet? Something so ordinary, so familiar, that no one would look twice. It would even make scientific sense. A layer of carbon and ice could mask heat signatures, scatter light naturally, and protect whatever lay beneath from radiation and detection. To our telescopes, it would appear as nothing more than a dusty traveler, a cosmic costume. Now, of course, most scientists refuse to entertain such thoughts seriously. It's one thing to note an odd chemical ratio. It's another entirely to imply intention behind it. Still, the question lingered in late-night discussions and speculative papers, the kind written more out of curiosity than conviction. Could 3I/ATLAS's unusual chemistry be the result not of accident, but of design? There were alternative ideas too, more grounded but equally strange. Some proposed that ATLAS came from a very different kind of planetary system, perhaps one richer in carbon dioxide and poorer in water than our own. Others suggested that during its ejection from its home star, it had passed through zones of intense heat that vaporized its water ice long ago, leaving only the more resilient compounds behind. Those explanations fit better with known physics, but still, there was that nagging detail, the timing, the speed, the sequence. Why did everything about ATLAS feel just slightly off? Astronomy, at its core, is a science of patterns. We learn the rules of the sky, then wait for the moment something breaks them. And 3I/ATLAS broke more than one. Its composition, its early awakening, its volatile balance, all seemed too coincidental, too contrived. Each anomaly might have been explainable on its own, but together they hummed like a chord of dissonance. Imagine the scientists watching the spectral lines scroll across their screens. Thin, colorful bands of light stretching from red to blue, each line a clue, each ratio a riddle, and there, among the patterns, was a fingerprint that didn't match any cataloged sample. A whisper of something alien, not necessarily intelligent, but undeniably other. Still, no one could prove it. No one could say with certainty that ATLAS's chemistry was unnatural. The data was real, the interpretation uncertain. In science, certainty is rare, and mystery is common. Yet mystery has its own gravity. It pulls minds toward it, drawing speculation like a comet draws its tail. As Atlas moved closer to the sun, the gases thickened, the tail lengthened, and then, just as suddenly as it had appeared, it began to fade again. Its chemistry changing once more, becoming even harder to interpret. Every image, every spectrum, felt like a glimpse through frosted glass. And then, as it slipped further away, the data stopped coming. The silence of the sky returned, but the questions remained. Why that much carbon dioxide? Why so little water? Why such early activity? Was it chance, or something that wanted to appear as chance. For now, the official reports would call it an enigma of composition, a puzzle of ice and dust. But beneath the cautious language, the whispers persisted. What if this wasn't just a comet behaving oddly? What if, beneath its crust of ice, it carried secrets we weren't meant to see? And as the scientists archived their data and turned their telescopes elsewhere, one thought lingered in the quiet of their minds. If the universe wanted to send a message, it might not come as a signal or a flash. It might come as something like this, small, silent, and wrapped in the perfect disguise of chemistry. Every scientific mystery begins as a question, and most end in data, but a few, a very rare few, end in a feeling, that subtle, uncomfortable shift between curiosity and suspicion. 3I/ATLAS had already crossed that line. Its speed, its chemistry, its early awakening, all had pushed the scientists watching it into quiet unease. But now, something darker began to take shape. It started as an offhand comment, buried deep in a late-night discussion thread among researchers. "If I wanted to hide something in plain sight," one astronomer wrote, "I'd make it look exactly like that." It was a throwaway line, but it lingered, half joke, half thought experiment. What if 3I/ATLAS wasn't a comet at all? What if it was pretending to be one? The idea was absurd on its face. The universe is full of oddities. You don't need aliens to explain strangeness. But once the seed of doubt takes root, it's hard to ignore. Theories began to branch and twine. What if this object wasn't a random wanderer, but a visitor? Or, worse, a watcher? Scientists called it, quietly, the disguise hypothesis. Imagine for a moment that somewhere out there exists a civilization millions of years older than ours. A people who have watched stars form and die the way we watch seasons change. If they wanted to explore the galaxy, to see without being seen, how would they do it? They wouldn't send shining ships or blazing signals. They would send something small, silent, and utterly ordinary. Something that could blend into the natural noise of the cosmos. Something that looks exactly like a comet. A comet, after all, is the perfect camouflage. It moves predictably, its surface messy and unremarkable, its emissions common and harmless. No telescope would track it with suspicion. No radar would sound alarms. To us, it would just be another rock among billions, except perhaps for a few faint irregularities. A little too fast, a little too early to awaken, a little too strange in composition. The more scientists ran the numbers, the more that unease deepened. If an object were designed to observe rather than collide, to pass through solar systems quietly, what better path could it follow than a hyperbolic one? In fast, out faster, leaving barely a trace. The thought lingered. Maybe the worst-case scenario wasn't that 3I/ATLAS could hit us. Maybe the worst case was that it could see us. Of course, none of this was proof. It was speculation piled on uncertainty. The disguise hypothesis wasn't a paper. It was a whisper. The kind that travels through academic corridors when no one's recording. To speak it aloud was to risk ridicule. And yet, it was strangely comforting in its way. Because if Atlas were natural, it made little sense. If it were designed, at least there was purpose. Still, the implications were heavy. If someone, or something, could create an object that looked this convincingly natural, what else might already be drifting through the dark unnoticed? You could almost feel the shift in perspective. Once the idea settled in, it became hard to look at the night sky the same way. How many comets have passed through, too faint for us to notice? How many asteroids have quietly slipped by? We look for radio signals, for beacons, for signs of intention. But what if the real intelligence hides inside the things we've already cataloged, disguised so perfectly we never thought to question them? The scientists, cautious as ever, grounded themselves in what they could measure. There were no transmissions from ATLAS, no signatures of propulsion or construction. Everything pointed to it being inert, dead rock, frozen gas, harmless. But the absence of evidence wasn't comforting. In some ways, it was worse, because a disguise only works if it leaves no clues behind. One researcher compared the idea to the camouflage of an owl in a tree. Invisible not because it hides actively, but because its stillness is perfect. If an alien probe wished to travel undetected, it wouldn't need to evade detection actively. It would only need to be still, quiet, plausible. That's what unsettled them most. Not the idea of contact, but the possibility of contact without acknowledgement. We tend to imagine first contact as something obvious. Lights in the sky, a clear signal, a handshake between species. But what if that's not how intelligence operates at scale? What if the galaxy is filled with watchers who never announce themselves, who only observe, record, and move on? To us, they'd appear as comets, as dust, as drifting relics of ice. And that's when the phrase, the worst-case scenario, began to take on a new meaning. It wasn't about collision or threat. It wasn't about invasion. The real fear was subtler. The possibility that we are being studied, unnoticed. That the eyes of something ancient have already passed over us, and we never even looked up. Perhaps it's not an accident that our first confirmed interstellar visitor, Oumuamua, behaved oddly, or that Borisov came soon after, or that Atlas III seemed to follow the same strange pattern. Maybe, some whispered, we're not just looking at cosmic debris. Maybe we're watching a fleet, slow, subtle, and spread across the stars. But such thoughts are heavy things, too heavy for public papers, too fragile for official press releases. So, the scientists returned to their data, describing ATLAS as an anomaly and leaving the rest to speculation. And yet, at night, under the still dome of an observatory, it was hard not to look out and wonder. Somewhere, across the black sea of space, other eyes might be watching back, patient, unseen, and disguised as dust. In the end, the disguise hypothesis remained what it began as, a question whispered in the quiet, not an accusation, not a discovery, but an unease that clung to the edges of the data. The numbers alone couldn't confirm it. The silence of the sky couldn't deny it. And as 3I/ATLAS slipped away into darkness, the feeling it left behind was colder than fear. It was curiosity, sharpened into doubt. The sense that maybe the universe doesn't just visit us by accident. Maybe sometimes it looks in on purpose. Speed in space is a strange thing. Down here on Earth, we think of motion as energy, as effort. A car's engine roaring, a jet breaking through the clouds. But in the vastness of the cosmos, speed is silence. There's no roar, no friction, no air to resist you. Once something begins to move, it simply keeps going. Unless something enormous gets in its way, it never stops. Even so, 3I/ATLAS moved too fast, far too fast. When astronomers calculated its velocity, more than 60 kilometers per second relative to the sun, the numbers felt unreal. It wasn't simply fast by human standards, it was fast by cosmic ones. To put it in perspective, that's about 216,000 kilometers per hour. A speed so great that light itself, bouncing from its surface, barely gave our instruments time to read it before it slipped away. The faster something moves, the less time we have to know it. Every interstellar visitor before, it had been fast. Oumuamua, then Borisov. But this one was faster still, as though each arrival were testing a new limit. The pattern made scientists uneasy. The speeds weren't just high, they were climbing, as though something somewhere was refining a method. But natural explanations came first. That's always the rule. Maybe Atlas had been thrown from a violent system, a star cluster where gravitational chaos flung objects outward like stones from a sling. Or perhaps it had passed too close to a giant planet, using that world's gravity as a slingshot to escape into the void. These things happen. The universe is filled with accidents. Still, the numbers wouldn't sit quietly. Simulations showed that even the wildest gravitational ejections couldn't easily produce an object with ATLAS's specific combination of speed and trajectory, not without improbable precision. Most ejected comets, when modeled, slow slightly as they move through interstellar space, their momentum eaten away by countless collisions with gas and dust. But Atlas showed no sign of wear. Its path was clean, untouched, as if nothing had ever slowed it. To those who looked closer, the possibility grew more unsettling. Maybe its speed wasn't an accident of physics. Maybe it was a choice. Imagine for a moment that an intelligence somewhere in the galaxy wanted to send something across the stars. not to arrive, but to pass through. A probe meant to observe, to listen, to measure civilizations from afar. What better way to ensure safety than velocity? A fast probe is a safe probe, too quick to intercept, too fleeting to threaten. It could slip through solar systems unnoticed, unseen, untouchable. If that were true, ATLAS's speed wasn't a mystery to be solved. It was a message to be understood. But that thought is heavy, almost impolite in the halls of science. So instead, researchers kept to the language of probabilities and error bars. They spoke of ejection velocity distributions and gravitational perturbations, while avoiding words like intent or design. Yet, late at night, when the data slowed and the hum of observatories softened to a whisper, that question hung in the air. What if the speed was deliberate? Speed leaves few clues behind. It's motion stripped of history. You can measure it, but you can't ask why. Astronomers ran more models. They tried everything: binary star systems, close encounters, ejections during planetary formation. The results always circled back to the same improbable truth. ATLAS was moving faster than it reasonably should. Each simulation demanded conditions so rare, so unlikely, that repeating them would require rewriting parts of what we thought we knew about cosmic mechanics. And then came the strangest part. When scientists projected ATLAS's path backward, tracing its trajectory through the galaxy, it didn't align cleanly with any obvious origin point. It seemed to come from nowhere, a direction empty of nearby stars. If you tried to find its home, there was only darkness. That emptiness carried its own kind of weight. Maybe that's why, in quiet moments, some astronomers spoke of it as a messenger from the dark, a traveler whose speed wasn't simply movement, but intention. Because in a universe this vast, there's a difference between drifting and arriving. And Atlas didn't drift. It cut through space like something that had somewhere to be. Of course, the rational explanations remain the loudest. They always do. Gravity, chance, cosmic coincidence, all were safer, simpler answers. But deep down, even the most grounded minds knew how rare those perfect alignments were. The odds of 3 interstellar objects, discovered within a decade, each faster than the last, each stranger than the one before, were so small that the word coincidence began to lose its meaning. Speed, it turns out, can be a kind of language. It tells you how something wants to be perceived, fast enough to avoid capture, slow enough to be noticed, just long enough to leave you wondering. So, when Atlas raced through the inner solar system, it did so like a whisper on the edge of hearing, a ghost of motion, fleeting and silent. Telescopes tracked it as best they could, but by the time the data came in, it was already fading. Even now, long after it's gone, we still don't know what drove it to move that way, or whether that drive was natural, or something far older and colder than chance. Maybe, in the end, that's what unsettles us most. Speed doesn't just move an object through space, it moves it through our understanding, slipping past what we can measure, escaping the reach of certainty. And as Atlas vanished into the dark beyond Mars, its trail fading into mathematical memory, it left behind a single quiet question that no simulation could erase. What if it was never meant to stay? If there is one thing the universe teaches us, it's how fragile things really are. Every object that drifts through space carries the scars of its survival, the pitting of micrometeorite impacts, the radiation burns of ancient starlight, the erosion of time itself. Nothing travels untouched, and yet somehow, 3I/ATLAS endured. That alone was strange enough to draw its own kind of wonder. By the time astronomers first noticed it, ATLAS had already been traveling for what could have been millions, perhaps even billions of years, through radiation fields, shock waves, and the magnetic storms of uncountable stars, over distances so vast that light itself needs eons to cross them. And yet, when it entered our solar system, it was still intact, still active, still alive, in the strange chemical sense that comets are alive, waking from deep cold and exhaling light. It shouldn't have been possible. Natural objects don't usually last that long. They decay, disintegrate, get pulverized by cosmic dust or cooked by radiation, until all that remains is fine particulate matter, lost to the interstellar medium. A small comet simply doesn't make that kind of journey and remain recognizable at the end. So, how had ATLAS survived? There were theories, of course, as there always are. Some suggested that it was shielded by an unusually thick crust of carbon, insulating its core from erosion. Others thought it may have spent much of its journey in the relative safety of interstellar voids, drifting through regions sparse enough that collisions were rare. A few even wondered if its composition was something unique, a kind of hardened material, dense and dark, that resisted radiation better than ordinary ice. But even these explanations felt like patchwork. They described possibilities, not probabilities. The math simply didn't favor endurance. For an object that small to remain cohesive after so much time, it would need not luck, but intention. And intention, as ever, is where science grows quiet. Still, one can't help but wonder. Imagine building something not for years or centuries, but for eternity. A structure meant to survive the cold and silence between stars. No engines, no power sources, no transmissions. Just a shape so simple and durable, it could drift forever, carrying within it whatever it was meant to preserve. Not alive, but not dead either. A messenger without a destination. If that sounds like science fiction, remember this. The oldest man-made objects now leaving our solar system, the Voyager probes, are doing something very similar. They drift through the dark, unpowered, unfazed by time. Their only defense against oblivion is their simplicity. A few metal plates, a record, a pulse of memory in a machine that no longer hears back. And so, perhaps, 3I/ATLAS was the same. An artifact of survival, a fragment from someone else's long, quiet civilization, still doing what it was built to do: endure. Of course, to most scientists, that thought is poetic nonsense. There are plenty of natural ways for objects to last. Ice can harden, carbon can protect. The universe is vast, and improbable things happen constantly. But still, there was something about Atlas's persistence that refused to fit neatly into randomness. The deeper the observations went, the more curious the details became. The spectral data suggested a strange richness in heavy carbon compounds, long chains, complex molecules that hinted at chemistry more intricate than simple frozen gas. Not artificial, necessarily, but unusual. It was as though the object had been armored by its own chemistry, wrapped in a kind of self-forged shell that had kept it whole. Maybe endurance isn't an accident of physics, but a form of memory, the universe's way of ensuring that some things last long enough to be found. The idea that survival itself could be a kind of intent, not conscious perhaps, but fundamental. The scientists studying ATLAS began to speak about it with a kind of reluctant reverence. You could see it in the way they described the data: resilient, persistent, stubborn. Words that belong more to living things than to rocks. Late at night, in quiet observatories, that language took on a weight of its own. There was a sense, unspoken but shared, that ATLAS wasn't just an object. It was a story that had outlived its author. Every comet tells a story about where it came from, about the light that once warmed it, the collisions that shaped it, the dust that settled upon it. But Atlas's story had no ending we could find. It had traveled too far, through too many unknowns, carrying with it the marks of time we could no longer read. It's hard not to be moved by that. Something so small, so fragile, crossing the galaxy without guidance, without fuel, without purpose, and still surviving long enough for us to notice it. Perhaps that's the real miracle. Not that Atlas was artificial, not that it was built to deceive, but that it existed at all, a relic of endurance in a universe that rarely allows such things. And yet, even as scientists reached for that comfort, a quieter thought lingered in the back of their minds. What if endurance was not just the result of nature's stubbornness, but the echo of design? What if the very act of survival was, itself, a message? Something that says, we were here. In the end, they could only record what they saw: light curves, chemical spectra, estimates of decay. But the feeling, the awe, the faint unease, that couldn't be plotted. It could only be felt, somewhere deep beneath the numbers, in the place where curiosity meets reverence. And as Atlas continued on its way, slipping back into the dark that had once carried it to us. That feeling remained. There's a kind of silence in astronomy that isn't made of sound at all. It's the silence of data, the absence of signal, the stillness in a frequency band where you expected to find noise. That silence can be haunting, because in science, nothing is ever truly quiet. Everything hums, everything radiates. Every atom in the universe is whispering in one way or another. So, when scientists turned their instruments toward 3I/ATLAS, they expected something. Not speech, not music, just a pattern, a pulse, some rhythm of radio waves that might betray an echo of activity. Every comet and asteroid produces some faint signature, charged particles interacting with solar wind, molecules resonating as they warm, a cosmic murmur that says, "I exist." But Atlas said nothing. Its silence was total, not even the usual crackle of static that accompanies charged dust. No radio emission, no microwave echo, no measurable hum. Just a void, a shape traced only by reflected sunlight, its signal drowned in the cosmic background. At first, that quiet was comforting. It confirmed what the data had always said, that this was a natural object, lifeless and inert. Yet the longer the silence lasted, the more it began to feel deliberate. You see, when something behaves exactly as expected, it reassures us. But when it behaves too perfectly, we start to wonder. That's the paradox of silence in the universe. It can mean peace, or it can mean presence. The radio telescopes listened anyway. Dishes in Hawaii, Chile, and Australia all turned their open metal faces toward the void. They listened through long nights, catching every flicker of background noise, every burst of solar interference, every meteor echo. And through it all, 3I/ATLAS passed silently, as if it were a shadow pretending to be a thing. The SETI arrays joined in too, not because anyone really believed this rock was artificial, but because the chance, even the smallest chance, was irresistible. It's a ritual as old as curiosity. When something comes from beyond the stars, you listen. You always listen. They scanned across wavelengths, searching for narrow band signals, the kind no natural source produces. They found nothing. They looked for pulsed emissions, radar reflections, unusual polarization. Still nothing. Just the empty, even static of the universe, humming softly to itself. But silence can be strategy. A truly advanced intelligence, some theorized, would have no reason to broadcast. Broadcasting draws attention. It announces your existence to everything, friendly or not, in the void. Far safer to remain quiet, to observe unseen, to let the universe speak while you listen. And that's what made 3I/ATLAS's quietness feel so uncanny. It wasn't the absence of noise that unsettled scientists, but the completeness of it, as if the object had been designed to leave no electromagnetic trace at all. It's the same feeling you get walking through a forest and realizing you can't hear any insects. The quiet doesn't soothe you. It makes your pulse quicken, your eyes search the shadows. Because silence, when it shouldn't exist, becomes its own kind of signal. Of course, not everyone agreed. The pragmatic voices, the ones who always speak loudest, reminded everyone that interstellar comets are faint, too small, too far. Radio silence was inevitable. The telescopes weren't failing to detect anything. There was simply nothing to detect. And yet, that explanation didn't quite dispel the mood that had settled over the observatories. For months, 3I/ATLAS continued its passage through the inner solar system. Each observation confirmed the same stillness. It glowed faintly in visible light, shed dust as it should, followed its trajectory precisely. But in every other spectrum, radio, infrared, microwave, there was nothing, not even the whisper of reflection. As it moved farther from the sun, the silence deepened, and as it faded into the black, it left behind a strange kind of empty. Because when you listen to the sky and hear nothing, you start to question what silence really means. Maybe Atlas was just another rock, dead and mute. Maybe it had nothing to say. But there's another possibility, more unsettling in its simplicity, that the silence wasn't accidental, that it was part of its disguise, A machine built to be undetectable would need to do nothing more than mimic the quietness of space. No signals, no interference, no trace of itself except for the faintest reflection of starlight. To us, it would look like the most natural thing imaginable. Perfect camouflage. The thought haunted a few of the astronomers long after ATLAS had vanished from sight. They would glance up at the night sky, at all the comets, the asteroids, the drifting ice, and wonder how many of these have passed by, silent and unremarked, because they were designed to be exactly that. We've always looked for noise in our search for company, for a flash of light, a pulse of code, a deliberate signal against the static. But what if the real presence in the universe hides not in sound, but in silence? Because silence, after all, is not nothing. It's the space between everything else. And sometimes that space feels like it's listening back. The idea began as a whisper, but whispers once heard are hard to forget. By now, everyone studying 3I/ATLAS had seen enough strangeness to admit what they couldn't fully explain. The speed, the chemistry, the silence. Each anomaly on its own was peculiar, but together they formed a pattern. The outline of something intentional hiding behind the illusion of accident. And so, quietly, the disguise hypothesis began to take shape. It wasn't an official theory, not something you'd find in a journal or conference proceeding. It lived between conversations, in the liminal space between science and imagination. The thought was simple, but unsettling. That maybe intelligence in the universe doesn't always announce itself. Maybe it survives by hiding in plain sight. Camouflage is, after all, one of nature's oldest languages. On Earth, it's everywhere. The mottled skin of an octopus, the ghostly transparency of a jellyfish, the color-shifting scales of a chameleon. Every creature that learns to hide does so to survive. Some do it to hunt, others to avoid being hunted. It's not malicious, it's just life, adapting to the gaze of others. So why should intelligence be any different? If life evolves beyond planets and oceans, into the cold wilderness of space, perhaps it carries that instinct with it. The instinct to conceal, to endure unseen. Because in a galaxy where danger can arrive at the speed of light, safety might mean invisibility. The disguise hypothesis suggested that what we call comets and asteroids could, in some cases, be engineered objects. Autonomous probes built to blend perfectly with the natural landscape of the cosmos. They wouldn't shine, they wouldn't signal, they wouldn't look or behave in ways that drew attention. They would drift like dust, their disguises so complete that even a civilization's most sensitive instruments would only ever read them as rock and ice, perfect mimicry. It sounds impossible, even fantastical. But so did flight once, so did radio, so did life itself. Every impossible thing eventually becomes ordinary, given enough time. And if there are civilizations out there older than ours, not by centuries, but by eons, then the art of invisibility might be as ordinary to them as a coat of paint is to us. To those who considered it seriously, the elegance of the idea was chilling. Imagine a probe designed to look exactly like a comet, its surface frozen, scarred, pitted with simulated impacts. Beneath the outer crust, hidden layers of shielding, sensors, perhaps even memory. The means to observe without revealing itself. It could pass through countless solar systems, gathering data, mapping stars, listening for civilizations, and all the while appearing entirely natural. No civilization would ever suspect it. They'd record it, categorize it, forget it, and the probe would move on. That's the genius of camouflage. It doesn't just hide the body, it hides the intent. Atlas fit the disguise perfectly. Too irregular to be artificial, too consistent to be random, a shape blurred by rotation, a chemistry almost plausible, a silence too complete. If something wanted to be overlooked, this was how it would do it. But then comes the harder question. Why hide at all? Maybe it's survival. Maybe it's curiosity. Maybe it's both. A civilization that has endured long enough to master such concealment might also understand the risks of being seen. Perhaps the galaxy is not a friendly neighborhood of explorers, but a forest of quiet watchers, each aware that to reveal oneself is to invite danger. The philosopher and astronomer David Brin once called it the Great Silence. He imagined the universe as a dark wood where every civilization whispers softly, afraid to make noise. The first to shout might also be the first to vanish. In that light, a disguised probe makes perfect sense. It's a way to learn without risk, to listen without being heard. And so, scientists began to notice something else about the pattern. The 3 interstellar visitors we've observed, Oumuamua, Borisov, and ATLAS, didn't just arrive. They appeared in sequence, each slightly different, each slightly more refined, like prototypes in a series. Each one faster, each one quieter, each one less explainable. Could that too be coincidence? Of course, it always could. But the human mind is not built to rest easy in coincidence. As the disguise hypothesis gained quiet traction, some researchers began to see echoes of intention, even in the randomness of dust. Maybe that's human vanity, the desire to see meaning where none exists. Or maybe it's intuition, the first faint recognition of a truth too large to face directly. In one late-night discussion, a physicist described it beautifully. Camouflage isn't just a way of hiding what's there. It's a way of making you believe nothing's missing. That line lingered, poetic, but terrifying. Because if the universe is filled with watchers disguised as dust, then we are surrounded not by emptiness, but by presence. A presence that doesn't need to declare itself because it has already mastered invisibility. Perhaps that's what makes ATLAS so haunting. It's not the object itself, but what it represents. A mirror held up to our own smallness, our assumptions about what intelligence should look like. We imagine machines shining and metallic, civilizations sending signals across the stars. But what if the real sophistication lies in doing neither? What if the greatest sign of intelligence is not communication, but restraint? Atlas, after all, left no signal, no message, no. If there's one question that lingers at the heart of every mystery, it's not what something is, but where it came from. For 3I/ATLAS, that question turned out to be the hardest one to answer. When astronomers traced its trajectory backward, trying to follow the faint curve of its motion to its origin, they expected to find a familiar neighborhood, a star system, a cluster, perhaps a known region of interstellar dust. But the math refused to cooperate. No single origin fit, no nearby star aligned cleanly with its inbound path. It was as if the object had emerged from a patch of darkness, a place between rather than from. And yet, there was one faint clue. The backward projections of its orbit didn't trace to the thin, flat plane of the Milky Way where most of our stars reside. Instead, the line extended towards something older, the thick disk. The thick disk of the galaxy is a strange, ancient realm. It's home to stars that were old before our sun was born, faint red relics from a time when the galaxy was still forming. Their light carries the fingerprints of primordial chemistry, low in metals, high in memory. These are the oldest suns, the quiet elders of our spiral arms. If 3I/ATLAS came from there, it meant one thing above all else, that it was ancient. Perhaps billions of years old. A traveler launched or born long before Earth itself existed. That realization changed everything, because if it was natural, then it was a relic, a piece of the galaxy's deep past, drifting between stars since before our species could walk. But if it was artificial, then it was something far more haunting, a messenger from a civilization that predates us by epochs. Astronomers began to call this idea, half-jokingly at first, the navigator hypothesis. It suggested that ATLAS might not be a comet at all, but part of a grander network, a system of silent travelers seeded through the galaxy to map its structure, measure its changes, and perhaps even observe the rise and fall of civilizations. Not invaders, not explorers in the human sense, navigators, archivists of time. If you imagine a civilization so old that even its home star might have burned out, then you begin to see why something like ATLAS would make sense. When your timescale stretches across billions of years, patience becomes strategy. You don't rush between stars and ships of fire and fuel. You let the galaxy's own gravity carry your instruments for you. You use nature as your engine. Maybe, in that distant age, the builders of such objects learned to let go of urgency, to send not emissaries but seeds, self-sustaining, self-concealing travelers meant to drift, to observe, to remember. The Voyager probes we've launched into the void today might look crude to them, but the intent is similar. We too have begun to send our messages into eternity, hoping someone, someday, will notice. So, what if 3I/ATLAS was one of theirs? A navigator probe set loose when the galaxy itself was young. It might not even be functioning anymore. It might just be coasting now, its purpose long fulfilled, its makers long gone. A ghost of an ancient mission, wandering still. Some scientists dismiss the idea outright, of course. The probabilities, the timescales, the assumptions, all too enormous to test. But others lingered on the poetry of it, because it fit too neatly with what we were seeing, the speed, the endurance, the silence, the camouflage. All of it could be features of a design meant for one thing: longevity. There was a moment in one late-night interview when an astronomer described it perfectly. If you wanted to map the galaxy, you wouldn't need to send millions of ships. You'd only need to build a few. That phrase, last forever, echoed in the quiet. Because maybe that's what ATLAS was really about. The endurance of memory across unimaginable time. You can almost picture it, can't you? A small dark object drifting between the stars. No lights, no engines, no voice. Just quiet sensors measuring the faint hum of cosmic background radiation, recording the slow song of the Milky Way's arms turning. It could have passed near 1,000 worlds before ours, watching the rise and collapse of civilizations, long erased from history, and each time it would move on, never staying, never interfering, just watching, just recording, like an ancient mariner charting the shorelines of a cosmic sea. The navigator hypothesis doesn't ask you to believe in aliens or gods or miracles. It only asks you to consider the possibility of persistence. That intelligence, once it exists, might not disappear. It might evolve into patience. Maybe the galaxy is already mapped. Maybe the data is already gathered. Maybe we, in our brief flash of civilization, are just the latest to look up and notice one of the instruments gliding past. And perhaps that's the real reason the thought is unsettling. Because if Atlas was a navigator, then we are not pioneers. We're latecomers. The maps have been drawn, the routes have been traveled. We're stepping into a galaxy that has already been quietly observed for longer than we can imagine. It's a strange kind of humility to think that way, but it's also comforting. Because if these navigators exist, it means that survival is possible, not for bodies, but for ideas. It means that across the ages, intelligence finds a way to endure. And maybe, in that endurance, there's something of ourselves reflected. Atlas has long since left our sky now. It's back in the deep, its path unknown, its light too faint for even the most powerful telescopes to see. But somewhere, far ahead of it, perhaps another waits. Or maybe it's already been here, and we simply didn't recognize it. Because if the galaxy is filled with navigators, then the stars above us aren't just silent witnesses. They're waypoints, markers on a map that's been unfolding for billions of years. And in astronomy, there's a comfort in math. Equations don't lie. They describe gravity's grip, light's speed, and the motion of worlds with unshakable precision. When we map the sky, we see order, orbits and ellipses, parabolas and hyperbolas, every object obeying the same rules. That's what gives science its peace. The universe, for all its chaos, plays by a set of laws. But what happens when the laws themselves can hide intention? 3. I/ATLAS followed a trajectory that seemed perfectly natural. A long, open curve, a hyperbolic path cutting through the solar system, looping close to the sun before sailing back outward into the void. It obeyed Newton, Einstein, and everything in between. No deviations, no sudden course corrections, no hint of propulsion. Every number matched what we expected from a comet flung by gravity alone. And yet, something about that perfection felt uncanny. If you wanted to disguise design as nature, what better way could there be than to make your creation follow natural law exactly? A trajectory so flawless that it invites no suspicion. A performance so convincing that it erases the idea of performance entirely. That's what some scientists began to whisper, not in their published reports, but in the quieter spaces between. They wondered whether a probe advanced enough to travel the galaxy would even need engines in the traditional sense. It could coast on gravity itself, slipping from one system to the next, using only the momentum of the stars, altering its path with microscopic precision, never burning, never flaring, never breaking disguise. A trajectory like that wouldn't defy physics. It would use physics perfectly. That was the unnerving beauty of the trajectories of intention idea. It didn't require impossible technology, only impossible patience. It imagined that 3I/ATLAS wasn't flying against the laws of the universe, but within them, guiding itself invisibly through the same mathematical harmonies that govern everything else. And how would we ever know? To our instruments, its movement would look exactly like that of a rock, predictable, explainable, clean. Because when intention hides within law, even truth begins to sound like coincidence. The astronomers who dared to entertain that thought began to see the sky differently. Every orbit, every passing object, every asteroid suddenly looked like a possibility. Not evidence, but question. What if some of them were travelers, not debris? What if we've mistaken navigation for randomness all along? It's a dangerous idea because it dissolves the boundary between nature and design. It suggests that technology, given enough time, might evolve to become indistinguishable from physics itself. Not machines in motion, but motion as machine. Imagine an object that adjusts its course not through thrust, but through its shape, by subtly reflecting light or bending its surface to use solar wind as sail. A body so finely tuned that it can shift direction over millennia without ever revealing that it's doing so. To us, its orbit would appear eternal, inevitable. We'd never suspect guidance because the guidance would look exactly like gravity. That's the quiet terror of the idea. It doesn't ask us to believe in aliens or magic. It only asks us to accept that intention might be invisible by design. And if that's true, then the universe itself could be full of such hidden trajectories, paths of purpose written in the language of physics. We'd never recognize them for what they are. We'd call them comets, asteroids, radiation streams, even the faint drift of interstellar gas, all of it possibly choreography. But of course, that's only speculation, poetic, maybe even absurd. Still, there's something in the data that resists complete dismissal. The precision of ATLAS's orbit, the way it curved past the sun with such balance, as though calculated for efficiency rather than chance. Even its angle of entry, steep, clean, and rare. It wasn't unique, but it was elegant. And elegance, as history has shown, is often the shadow of design. Late one night, an astronomer compared ATLAS's motion to a stone skipping across water. Each skip looks random, they said, but the throw that caused it wasn't. That image stayed with many of those who studied it, because maybe that's what we're seeing, not the act of creation, but the after effect of intent. A motion launched long ago, still playing out, still echoing through time. If so, then every interstellar object we've found could be part of a pattern too vast for us to see, each one a fragment of a greater geometry, the galactic dance of things built not for speed or power, but for endurance and invisibility. That's the strange thing about trajectories. They tell you where something is going, but not why. The path alone cannot reveal purpose. The math doesn't carry motive, it only describes motion. And yet, when the motion is this perfect, it's hard not to feel the faint presence of thought behind it. Something that has mastered the art of leaving no fingerprints. For now, the records of 3I/ATLAS remain what they've always been. Numbers, plotted points, a fading streak across our instruments. But to some, those numbers read like script. A kind of writing written not in words, but in movement. And if motion can carry meaning, then perhaps we've already been reading messages from the stars without realizing it. Tracing their curves with telescopes, charting their paths, and calling them coincidence. Maybe patterns are how the mind protects itself from chaos. When we see repetition, our brains relax, as though order itself is a kind of safety. But sometimes, finding a pattern only deepens the unease, because once you see it, you can't unsee it. That's what began to happen with 3I/ATLAS. At first, it was just another anomaly, a strange visitor from interstellar space, joining the brief list of cosmic wanderers we've been lucky enough to witness. But when astronomers compared its traits to those of the two that came before, Oumuamua in 2017 and Borisov in 2019, a quiet tension began to form. 3 objects, 3 interstellar travelers, all detected within a single decade. For context, before Oumuamua, not one had ever been observed in the entire history of astronomy. The odds of seeing even one in a human lifetime were considered microscopic. Yet, here they were, arriving in sequence, one after another, as if on schedule. Coincidence, said most. The improved sensitivity of telescopes, the expanding sky surveys, the luck of modern detection technology. That explanation worked for a while, until the details began to line up too neatly. Each of the 3 shared the same broad characteristics: hyperbolic orbits, interstellar origins, and strange deviations in their behavior. Each was also faster than the last, their trajectories increasingly clean, their chemical signatures increasingly hard to explain. Oumuamua was the first whisper, cigar-shaped, reflective, accelerating slightly as if pushed by something unseen. Borisov followed, less mysterious, more comet-like, but still moving at a velocity few natural models could comfortably explain. And then came Atlas, faster still, stranger still, leaving even fewer answers than before. 3 anomalies form a line, and lines, in science, demand attention. If you plot their arrival dates on a timeline, they form an almost rhythmic cadence, not quite periodic, but eerily consistent with the time it might take for a set of scouts or instruments to sweep across the galactic arm, passing one system after another. Of course, that idea sounds uncomfortably human. We like to imagine purpose where there might be none. But even the cautious minds began to pause, because probability alone could only stretch so far before snapping. It wasn't just the timing, it was the composition. Each object's chemistry had its own oddities, ratios of gases that didn't fit known comet models, patterns of activation that occurred too far from the sun. These weren't identical twins, but cousins that shared a strange genetic echo, each one natural enough to pass inspection, each one just wrong enough to leave a question behind. It began to feel less like coincidence and more like iteration, the way engineers build prototypes, each refining the last. The idea was absurd, but also unshakable. If the first object was a test, the second was refinement, and the third, 3IATLAS, was perfection. It was as if the galaxy itself were learning how to hide in plain sight. That's when the tone of the research changed. Scientists began to speak not of anomalies, but of possibilities. The papers grew more cautious, their language softening under the weight of what it implied. You could unusual properties, non-gravitational acceleration, unexplained resilience. It was the language of curiosity wrestling with fear, because if there really was a pattern, it wasn't a pattern of collisions or debris. It was a pattern of intent, and intent changes everything. Imagine for a moment that the universe is filled with civilizations too careful to be seen. They send out their messengers not as blazing ships or beams of light, but as humble rocks and icy fragments. They don't announce themselves because they don't need to. They've learned the wisdom of patience, that to survive, one must blend in. We would never notice them, not until the number of coincidences grew too large to ignore. And maybe that's what's happening now. The slow revelation of a truth that's been in front of us all along. Not invasion, not contact, not even communication. Just observation. Just the quiet passage of watchers who have crossed this way before. The troubling part is what this might say about us. If these visitors are deliberate, then their timing is meaningful. They've come when we've become visible, when our radio waves have begun to leak into space, when our cities have turned the night into light. Maybe they've always been watching, but only now have they turned their gaze directly toward us. Or maybe, more chillingly, they haven't noticed us at all. Maybe they pass through countless systems, indifferent to the worlds that spin below them. To them, we're nothing more than another data point, another brief spark in the long map of galactic time. That's the other side of the pattern, not presence, but indifference. And yet, there's something strangely comforting in that idea too. Because if this is true, if these objects are travelers, if this is the quiet hum of ancient observation, then we are not alone in the way we think we are. We share this galaxy not with conquerors or saviors, but with witnesses. It means that even in our smallness, we are part of something immense, a story that stretches backward beyond comprehension. When you step outside on a quiet night and look up at the stars, you're seeing not just light from the past, but perhaps paths once traveled, ancient trajectories that cross and curve invisibly between those suns. Each line a story, each traveler a question. And somewhere in all that vastness, maybe another is already on its way, moving faster, hiding better, designed not to be found until, just by chance, we find it again. And when we do, maybe we'll tell ourselves it's coincidence one more time, because in the end, all the data points fade. The brightness curves, the velocity graphs, the spectral lines, they're just marks on paper now, static on servers, faint echoes of light that once touched an instrument and then vanished into memory. 3I/ATLAS is gone. Out beyond the reach of even our most powerful telescopes, it sails into darkness, silent as the day it was found. But its passing left something behind, not a message, not a signal, but a question. The scientists who tracked it still speak of that question the way sailors once spoke of ghost ships, with a mix of reverence and unease. Because what 3I/ATLAS revealed, more than anything, wasn't about chemistry or motion. It was about perspective, about the smallness of our certainty in a universe that refuses to sit still. For centuries, we've comforted ourselves with the idea that what we see is what's there, that the universe is a stage, and we are its newest audience, clever enough to understand its script. But every now and then, something crosses that stage and reminds us that maybe we've joined the play halfway through. That's what 3I/ATLAS felt like. A single line in a story that began long before we were here to read it. And that brings us to the real worst case. Not collision, not invasion, not extinction. The real worst case is that we're not the first ones watching. That the sky above us, quiet, beautiful, and seemingly empty, has always been filled with eyes that do not blink. That the silence we take comfort in isn't emptiness, but a kind of observation so subtle we never learn to notice it. Maybe that's why the universe seems so calm, not because it's empty, but because everything within it has already learned the cost of making noise. If the disguise hypothesis is true, even a little, then our search for company among the stars has been naive. We've been listening for voices when we should have been studying the silences. We've been waiting for light when we should have been paying attention to shadows. Perhaps the galaxy has never been quiet. Perhaps it's just been whispering in a language made of movement, patience, and stillness. And maybe that's the most haunting realization of all, that we were never alone, only unnoticed. But there's another side to this story. One not of fear, but of perspective. Because if watchers exist, if there are navigators drifting unseen between the stars, then the universe is not hostile. It's careful. It's ancient. It's full of patience we can barely imagine. We often think of intelligence as loud, as invention, communication, discovery. But maybe real intelligence is something quieter, something that endures, that listens, that chooses invisibility over dominion. And perhaps, in time, we'll learn that the watchers we fear are not our enemies, but our teachers. That their silence isn't a threat, but an example. That to survive across billions of years, one must learn to move softly through the dark. That thought isn't frightening, it's humbling. When you strip away the fear, the mathematics, and the speculation, what remains is something simple and strangely beautiful. A reminder that we are not the center of the story. We are participants in a conversation that began long before us and will continue long after we're gone. And maybe, just maybe, 3I/ATLAS came close enough for us to hear a fragment of that conversation. So as it fades into the deep, we're left not with certainty but with awareness that the cosmos is vast, alive with motion and silence, and that somewhere in that stillness, we are being seen. The worst case, then, isn't that they're out there watching us. It's that they've always been watching, and we've never thought to wave back. So, tonight as the stars begin to bloom across the sky, let yourself imagine that some of them aren't just stars at all. Maybe one of them is a traveler, gliding quietly between the suns, recording what it sees. Maybe it's looking down at us now, not as curiosities, but as part of the same long story of endurance and curiosity that binds everything alive. And maybe that's not a reason to fear the dark, but to marvel at it. Because if there are watchers out there, then we too are part of what makes this galaxy worth watching. Perhaps the galaxy has never been silent. Perhaps we just never knew how to listen.